This one says, pictured are fraction of molecules versus molecular velocity or speed for two gases at 300 Kelvin. Which gas has the higher molar mass? Well, for this one, there's a couple equations. So again, and first of all, the fraction of molecules, my printing and copying didn't come out very well, but this says fraction of molecules, so the y-axis is the same as the previous one. But the x-axis is now molecular velocity or speed. And again, there's a distribution of velocities or speeds. And actually, let me jump in here. Can anybody tell me the difference between velocity and speed?
Velocity has a direction.
Thank you. Velocity has a direction. And so a speed could be 55 miles an hour or 200 meters per second, while a velocity would be 55 miles an hour east or 200 meters per second north or to the left. So with a direction. Velocity being a vector and speed being a scalar, if you will. So just a number. So a number. Or another word for a number is magnitude. Whereas velocity is a vector. So has magnitude and direction. And I don't mention that so much for this course, but for those of you who have taken other courses, just to relate the difference there. So thank you. Now, so there are two equations that I think of when I think of speed for this. One is that the average kinetic energy is proportional to temperature. And then I think that kinetic energy is equal to 1/2 mv squared. And the way I put those two equations together, well, one more thing I can do. If I do the average kinetic energy, then it should be the average velocity. And I am not proving that, but that is true. I'm happy to discuss more. But let's read over this question. So these two gases are at the same temperature. So that means they will have the same average kinetic energy. However, if one of them has more mass, then that one must also have lower velocity or lower speed. Which means that if the question is which gas has the higher molar mass, it's going to be gas A because it is moving more slowly. And we could also add to that more slowly on average, because you can see some of these particles of A are moving faster than some of the particles on B. However, on average, B is moving faster. These are the two kinds of Boltzmann distributions that you will see. And so it's important to look at the x-axis. Is the x-axis velocity or speed of the molecules, or is the x-axis kinetic energy? Any questions about that? Okay.